Hi and welcome back. In this quick tech explorations video, I'd like to talk a little bit about the NRF24L01 Plus breakout board, which allows you to add really fast, reliable and cheap wireless connectivity to your Arduino projects. So what is this module? Here it is. It's a very small board, just a few centimeters across width and height, and right in the center it's got the integrated circuit that makes everything possible. So that's a circuit from Nordic Semiconductor. So it's got a lot of really amazing features for the device of that size and price. So of course there's high reliability, there is a very high speed, can go up to 2 megabits per second. It's got very low power consumption, just 14 milliamps at peak for receive and transmit of current draw. And according to some people, it can go running for years on a few AAA batteries, if you of course are able to do some good power management on the Arduino itself with sleep modes, etc. The communication with the Arduino is via fast SPI, and as I'm going to show you later, there is a very easy to use Arduino library that hides a lot of the complexity inside this chip. In terms of range, again, people report up to 100 meters out in the open space with the integrated antenna. I've tested it around the house, so I was able to see it working properly without any dropped packets, moving from one room to the other, probably at a distance of maybe 15 meters with 2 walls and a couple of doors between the receiver and the transmitter. If you add an external antenna, then again, some people report up to 1 kilometer of range, which is pretty amazing for a device of that size. Now, onto the demonstration. These are the connections. Most boards that I've seen on eBay don't have any markings on the breakout itself, so it's good to have this little schematic handy. So you can see that the pins on the breakout come in 2 columns, and you've got the IAQ, MISO, MOSI, the clock, the device enable and select. And just be careful of the power. This is a 3.3 volt device, not 5 volts, so take care to connect it in the right pin on your Arduino. And you can see the matching pins on the Arduino Uno. So MISO will go to pin number 12, MOSI to 11, clock to 13, CSN to 10, CE to 9. The IAQ I did connect it, but I was having trouble getting it to work. Even the supplied example sketches don't work with the IAQ setting, so I'm still trying to figure out how to get IAQ to work. And it's not much about this on the internet, so I will probably come back and add this to this lecture once I can figure it out. So at the moment, the sketch that I'm going to show you is a sketch that doesn't use IAQs, so it will block the execution of the sketch while transmission and receiving of packets is happening. Okay, so I think that a good place to get started is at the very end, so you can see what the end result of this little experiment is going to be. So I've got a transmitter here and then the receiver on this side. The modules are identical, and the only thing that makes this a transmitter and this a receiver is this, is this yellow wire here, which is connected to digital pin number 7. So when you have this wire grounded, the sketch picks it up and it connects and it gives this Arduino role to be the receiver. If that wire is not connected to anything, it's just hanging, then it's going to be the transmitter. The other thing that I've done is that I have connected an LED to digital pin number 6, so that when the transmitter sends over the A character, then that LED is turned on. Any other character is off. Now the sketch that these two Arduinos are running is identical. They both run the exact same sketch. The difference is that if the digital number 7 pin is grounded, then that sketch tells this Arduino to be a receiver. The transmitter randomly sends one of the 24 letters of the Latin alphabet to the receiver. So it could be any letter from A to Z. The receiver will pick it up, get the letter. If the letter is an A, then the LED will match. A couple of things about the circuit. As you can see, there's not much going on. If you can read the schematic with the pinouts, and you can put it together yourself. But just a couple of things to notice is that, number one, the module has got the pins in 2 columns, the one next to the other, and because of that you can't just take it and stick it onto a breadboard. That's not going to work, because then you're going to have shorts between the adjoining pins. So I had to use a ribbon cable to get it connected, and then little jumper wires to finish up the connections with the Arduino. So you can find these cables on eBay. They're pretty handy and very cheap as well. What else? Oh yeah, one more thing. I was having quite a few problems with dropped packets on the receiver end, and then after a lot of fiddling around, I realized that the problem was with the 3.3 volt power to the module. So this was a little bit unstable and was probably powering off and on the module too quickly. It was a bit loose, so that's why I used a bit of tape to get all the connections nice and tight and not moving. So that's about it with the hardware. So let's do a quick walk through the sketch. This is a modified sketch from the examples that come with their library. I've added a couple of things that control the LED. I'm going to show you what those are. I'm not going to concentrate on the many details in here. The sketch can essentially be just a plug and play. There's not many things that you need to modify. So one thing that I've added is just a constant that points to pin number 6 that I have the LED connected to. And then a little change that I've made was in the creation of the radio object, which is of type RF24 test. I just changed the SPI pins to 9 and 10 as per my circuit. Another interesting thing, here we've got the roll pin, digital pin number 7. So if you have connected digital pin number 7 to ground, then that Arduino will be the receiver. If it's hanging, if it's high, then it's going to be the transmitter. An interesting feature here is that communication between those modules happens via pipes. So pipe, like a connection between two of these modules, and each pipe has an address, right? So it's something that confuses people. It's not the module itself that has an address, but it's the pipe that the module uses to communicate with other modules. So because the circuit that I'm playing around with here uses essentially a duplex communication with its pair module, I need to have 2 pipes defined, or I need to have 2 pipes, two pipe addresses. So these are the 2 pipe addresses. If you're curious about the details, then have a look at the documentation. So if you go and have a look, you can see that this is the open writing pipe, and as a parameter it receives an address, And then a little bit further down, you've got the open reading pipe, which as parameters, it receives one of 6 possible pipes that can be opened at any given time, plus the address. Right, so really nice documentation here, by the way. Further down, I have a data type defined that allows me to define these 2 rows, out or back, so a transmitter essentially or a receiver, and friendly names for debugging purposes. Alright, I'm going to skip a few details, so I'm going to highlight this, which is a character array. Contains the letters of the Latin alphabet, and then I'll be picking one of those letters randomly and transmitting it to the other end. Let's have a look at the setup function now. So in the setup function, I define the purpose of the couple of digital pins up here. Then I go to roll pin, which is number 7, and take a reading. And then if that is high, then this Arduino is going to be playing the role of the ping out, or I call it the transmitter. Easier to understand for me. Otherwise, if it's low, then it's going to be the receiver or roll pong back. Once I take those readings, I print out some details of the connection, especially the role that this Arduino has, so I can see it. Then press a button to start, so that we can start with actually receiving or transmitting data. So once we press a button on the terminal, we'll start the radios. And then we configure the radios depending on the role of the Arduino. So if the role is ping out, so transmitter in other words, then the open writing pipe is going to be the one with the address from the first cell of the pipes array. And then the open reading pipe is going to be the one from the second cell of the pipes array. Otherwise, if the pin number 7 is low, then we're going to open up the pipe address for writing from the one that is an address number 1 from the array. Otherwise, we're going to open up writing pipe, the one with the address at cell number 1 of the pipe array, and for reading is going to be the one with address from cell 0 of the pipes array. And start listening in any case. Now inside the loop, essentially we've got 2 programs in one. First one is the one that will be executed by the Arduino that has roll ping out. And the second part of the program will be executed by the Arduino that has the role of the pong back, so the receiver. Have a look at the transmitter first. It's pretty simple what is happening. In order to transmit, we need to first stop listening. So we say radio.stop listening just to make transmission possible. Then I'm going to grab a random value from 0 to whatever the character array that I created earlier is. I'm going to get a random number between those two, ends, minimum and end maximum. And then I'm going to go and grab the letter that is at that index and store it temporarily in this character variable. And to transmit it, I just say radio.write and I pass a reference to that character variable, and this is just the size. I know that I've only got a single character here, so it's just a single byte. You could send lots of bytes together, so you just need to let the write function know how many bytes you actually want to send in one go. And now we stop listening. I'm going to stop here and skip to the second part of the program to see what happens at the other end. So at the other end, the receiver, so we add pong back. The receiver is going to check to see if there is data available, so radio.available. And it's going to be receiving data when it's, while the data is being received, we'll read it. So I've already defined a transmission character variable, and then radio.read. We're going to pick up whatever is in the buffer, and we'll put it or store it in the transmission variable. And we also need to tell it how many bytes is it that we want to store. So again, I've got a single byte here, so I could just have this replaced by number 1 instead of the size of transmission. So that's as easy as it is to take a reading from the module, from the buffer of the module. Just say read, a place to store the incoming data, and the size of the incoming data is all we need. Then we're going to print it out onto the screen, just like that. If the transmission happens to be in a character, then turn the LED at LED pin on, otherwise turn it off. Wait, and then do the whole thing again. Once there is nothing left to receive, then stop listening and start transmitting. So we want to transmit an acknowledgement. So I'm saying here that if everything goes well, I want to send back an OK message. So I'm storing that in a char array. And then just like we saw in the transmission part of the loop function, just say radio.write. Here's the thing that I want to send, and here is its size. And start listening again. Now let's go back to the second part of the transmission part of the loop function. So up here, once we transmit a message, then we start listening for an acknowledgement. This is not strictly necessary. I'm just timing here to see how long it takes for an acknowledgement to come back. But essentially, what I want to do, hold on a second, down here is to read the message that the receiver is sending back. So again, I know that I'm going to be getting a 2-character message, so I'm creating a character array with 2 cells in it. I'm going to use the read function to grab the response and then store it in the response temporary variable. And that's the size. I could have just said 2 here instead of size of response. Once I have the response stored in the response variable, now print it out. So I'm using printf, got response. Here's a modifier for characters. It's probably the easiest way to do it is what I've done here, because I've got a character array and I know that it's got 2 characters in it. Then I've got the %c character modifier here and here twice, one for each character. So I go and I grab the first character and print it out, and then grab the second character and I print it out in the corresponding character modifiers here. I suppose you could have done it like this, but that spits out as well the terminating character in the array, which I don't quite like. So for this little simple example, I prefer to go with the %c character modifier, and then I have my returns. It's about it, finished. And wait for a few milliseconds and then go ahead and retransmit. Right, so have a look here. My 2 modules are still transmitting and receiving, and it's all looking good. So that's about it with this short or relatively short lecture. So a quick example on how to use the 2 really capable RF modules, or this RF module. If you're curious to know what else you can do with these modules, then have a look at the Arduino Playground and you'll see what other things people have done. Especially what I find interesting are mesh arrays. So it's something I'm going to try out myself as soon as I get some time. So you can have multiple RF modules spread out over large or small area, and then those are able to communicate with each other and spread messages, for example sensor messages around, perhaps until it hits a gateway, and then through that to the internet. There's some really nice reading to be done here, and some really good ideas for potential users of this technology.